Well, hardware is really a function of the application. So when I look at any robot application, I think, okay, do I need something that can pick up an engine block, or do I need something that can pick up, as is most of the time for me, a microtiter plate? One is, say 400 kilos. The other one is 500 grams maximum. Mm-hmm. So, that's the first kind of order of business, is to look at the mechanics and be upfront as to whether there's going to be a solution built around something I can offer. From there, it's now a function of what is the business model surrounding how the robot's going to be implemented. So, for example, robots end up in the real world in many different ways and through many different mechanisms. If you go to a car plant, most of those came from a systems integration company. So there's a custom system builder that takes a robot that has nothing on it and develops tooling completely specific to making one piece of a car. If you go into a car factory, almost every gripper on every robot is slightly different or majorly different, depending on what its purpose is. And that's a bespoke solution, and the result is you get this very organic apparatus at the end. It's a car. I mean, it's amazing you can build a car with so much robotics and not so many people. And that's for good reason, because most of those processes are dangerous, handling heavy things or welding torches and things like that. But in my business is primarily handling a common shape. So it's a rectangle, it's a microtiter plate. So we're really just looking at, okay, can the robot work with all of the instruments necessary to complete a process? And that process could be anywhere from diagnostics, as we're seeing in the COVID-19 situation, to research and development. That's also related to the current situation as well, because pharmaceutical products are really products of years and years and thousands, tens of thousands of man hours of research, and the robots compress time for them. Right, so it's not doing something necessarily that's too dangerous most of the time, but handling blood samples is an exception to that. But most of the cases, it's not really taking danger out of the scenario. It's taking repetition, and it is impossible quantities of repetition. So what you can do with a robot arm and a system that fits in the corner of a room would take several roomfuls of people to do in a lot longer period of time. So it's not even a question of people versus robots. Yeah. You do it with a robot or you won't be in business. That's the simple, the simple approach. It's a different way to look at it. But, from there, it's just, once you mechanically figure out how the system's going to work and look like, software is important. What you want to do is spend as little time on the software as possible. You don't, developing robot code, maybe it sounds like good resume material, but when it comes to deployment, that's the thing that most organizations don't have the time in the whole system timeline to focus on. So we spend a lot of time focusing on how to minimize the amount of efforts used in software development.